Session 3.1 Summaries for Symmetric Distribution. For the Chapter 3, we'll be focusing on the numerical data, the center, and the variation. So we talk about the Chapter 2, the Session 2.1 and 2.2. When dealing with numerical data, you need to describe the distribution using these three characteristics. Remember what is it? The shape, the center, and the spread. Write it down here. I give you guys 1 minute. Okay, the shape. It can be symmetric. Symmetric is talking about the normal distribution or uniform distribution. Or it can be like skewed to the right or skewed to the left. The center. Center will be the typical value. Usually it happens on the highest frequency one. The spread out of the data, this is talking about the horizontal variability. Okay, this part we learned it from the chapter 2. In this chapter, we learn specific ways to describe the center and the spread of the distribution. The first one will be talking about the mean. Do you guys remember this guy? You may learn it from the math class, how to find the mean, how to find the standard deviation. The mean, you could think about it is going to be the average. It's just like this one, the balancing point of the distribution. So before we learn how to finding the mean using the formula, I want you guys look at the distributions. So this is going to be the symmetric distribution. Remember symmetric? It's just like you draw the line in the middle. The left side is roughly equal to the right side in here. Okay, so when we look at this symmetric distribution, you're gonna tell the typical value will be about like 24 here. Okay, and this is the dot box shows the distribution of ACT score for a sample of a statistics students. For the symmetric distribution, the mean is a good representation of a typical value of the data set. So we just say that the typical value should be about like 24. Do you guys see the little triangles here? Is pointing about 24.6 or 24.7 like this. So this is talking about the mean. And the mean is really close to the typical value. So that's why we say the mean is a good representation of the data set when you have the symmetric distribution. Okay, keep in mind, when you have the symmetric distribution, the mean is a good representation of a typical value for the data set. How about the skew distribution? It can be skewed to the left or skewed to the right. This distribution shows the salaries of professional baseball players in 2010. Do you think the mean is a good representation of the typical baseball salary for that year? So first, think about it. When I look at this skew distribution, the typical value should be from about 0 to 1. That would be the typical value. But if we added up all the data and then find out the mean, you're gonna find out the mean is about 3.1 or 3.2 in here, in this point. So we could see the mean is not a good representation of the typical value when you have the skew distributions. Using the mean to describe typical values. The mean represents a typical value in a set of the data when the data is roughly symmetric. Okay, roughly symmetric. This is talking about when you have a normal distribution, the bell shape, or the uniform distribution. The frequencies are about the same. then you could use the mean to represent the typical value. However, for the skew distribution, the skew to the right or skew to the left, the mean is not a good estimate of a typical value, just like the previous example. Now, we need to know how to find the mean using the formula. For the small data set, you want to add the data values, divide by the number of numbers. So you're gonna count how many data do you have. Okay, this is the formula. The mean equal to sum of the items, sum of all the data, divided by number of the items. Okay? If we write it in the notation form, you're gonna be like this guy. I want you guys write it down. This one, you do have an X bar here. This is represent the mean. This is the notation of the mean. And remember, what is this guy? This is the summation notation. Summation notation means you want to add up all the data. Okay, the X represent your data. And then divided by N. This is like how many data do you have in here. Okay, one more time. I need you guys remember all the notation in here. Later on, when we're working on the hypothesis testing, you will see those notation a lot. I need you guys remember what does this guy means, what does this guy means, and what does this guy means. This is how we using the formula to find the mean. For the large data set, use some kind of appropriate technology. We'll be using the TR-84 plus calculator. Okay, look at this example. Suppose a sample of price for 1 gallon of regular gas at 10 different gas stations in the neighborhood in Austin, Texas is taken on 1/4 day in 2013. Find and interpret the mean. So first, before finding the mean, I want you guys using this data to construct the dot plot. Remember what's the dot plot? Try. Okay, this is my dot plot. Okay, check your work and you're gonna count how many data do you have. It means like how many dots do you have. So what do you think a good estimate could be for a typical gas price for that neighborhood? Would be the mean? Okay, let's check. So now we're gonna calculating the mean using this formula. Okay, write down this formula one more time. I need to see the mean, the notation of the mean. Okay, so X bar equal to add up all this data and divided by the number of data. Okay, so you do have a 10 data, you should find the mean will be 3.02. And then interpretation of the mean. What does that mean? The typical price of 1 gallon of gas at this gas station in Austin, Texas was $3.02 on this particular day in 2013. Okay, so this is how I interpret of the mean in here. Okay, we're calculating the mean as a 3.02. So on the dot plot, I'm gonna point it in here, 3.02. So do you guys think mean is a good estimate for the typical value? Not really, right? The typical value may be somewhere like here. but your mean is going to be 3.02. So mean is not a good estimate for the typical value in this example. Okay, now I'm gonna teach you guys how to use the TI-84 calculator to do this example. So you may want to look at your notes, follow this instruction, and then let's do it together. Okay, so first, click on the stat, number 1 added. So I'm gonna put my data on L1. Remember how to clean it up? You're gonna highlight the L1 and then click clear and then enter. Okay, let me clean up the L2 as well. Click clear and then enter. Now, I'm gonna input this data. Okay, highlight the last data. We do have a 10 data. The last one will be 2.97. Okay, now we're gonna click on the stat, go to cal, and then enter for one variable statistic. Okay, my list is gonna be on L1, and I'm gonna go to calculate. So you're gonna see mean, the sample mean, the X bar will be equal to 3.024. Exactly the same thing. We just want 2 decimal space instead of 3 decimal space. Okay, you could see the summation of X equal to 30.24. So this is summation of X. And then we also have the N. The sample size is gonna be 10. Okay, so this is how you guys finding the mean. Measuring the spread of the data. After we talk about finding the mean, we're gonna talk about the variability. So remember, the variability in the distribution can be measured by the horizontal spread. Why care? We need to know if most of the data is near the center or far from it. So we talk about this on the session 2.1 and 2.2. We want to see how spread out of the data means if all the data is going to be close together or they're going to be far away from each other. So let's look at this example. The following histograms record the daily high temperatures in degree Fahrenheit over one recent year at 2 locations. So you could see this is the temperature in Provo, the Utah, and this is the temperature in San Francisco. From these two distributions, you could tell the variability of the temperature in the Provo is much greater than the temperature in San Francisco, because you could see all the data is going to be spread out. However, for the San Francisco, the temperature is really close to each other. Okay, let's compare these two distributions. Both distributions have roughly the same. Symmetric, this one not really, it's the symmetric one, right? But they say it's about the symmetric. Second one, the center. The mean is 67 Fahrenheit in Poro. So 67 is somewhere like here. That would be the center. And 65 Fahrenheit in San Francisco. So 65 is somewhere like here also. So you can see the mean of the temperature in these two cities is about the same, 67 Fahrenheit and 65 Fahrenheit. It means like if I don't give you guys the distribution, I only give you guys a set of the data. When you calculate the mean, they won't tell you how spread out of the data for each city. So one more time, look at this distribution. The pole is gonna be, the temperature in pole is more spread out. Data's values far away from the center. Okay, so center you could think about like the 67 Fahrenheit in here. But for the San Francisco, the data is less spread out. The data values closer to the center is really, really close to the mean. Okay, the mean is 65. So if I give you guys the distribution, you could easily to tell me which one has a higher variability. However, if I only give you guys the data set, how would you know? So we need to know how to calculate the standard deviation. What is a standard deviation? A number that measures how far away the typical observation is from the mean. For most distribution, a majority of the data is within one standard deviation of the mean. So think of the standard deviation as the typical distance of the observation from the mean. At this part, let me explain a little bit. Okay, let's say I do have a normal distribution. Okay, this is the bell shape. So in the middle here, this is gonna be my typical value, or this is gonna be the mean. Okay, the highest point in here. So what is a standard deviation? Standard deviation is talking about I will measure the distance from the mean to here. Like here, I would say this is a 1 standard deviation. And same idea, this is a 1 standard deviation below the mean. Okay, 1 standard deviation above the mean. This is a 1 standard deviation below the mean. So we could say this part, most of the data will be within 1 standard deviation. Okay, 1 standard deviation. The S represent the notation of the standard deviation. Okay, think about it. Let's say this time my data is more spread out like this. And then here, this is gonna be my mean again. Since most of the data will be within 1 standard deviation, okay, within 1 standard deviation. So this time when I calculate the standard deviation, the first standard deviation will be looks like here. Okay, 1 standard deviation above the mean, 1 standard deviation is below the mean. You can see the majority of the data is going to be lying in here. So when I compare these two pictures, this is my picture 1, this is my picture 2. Okay, I'm gonna put this is gonna be my first standard deviation. This is the S2, represent the graph of the two. S1 will be the standard deviation of picture 1, S2 will be the standard deviation of the picture 2. So you can see when I compare the number, the standard deviation 2 will be greater than the standard deviation of 1. So it means when you're finding the standard deviation, you're gonna know how spread out of the data for each distribution. If the standard deviation is smaller, then it means the data is gonna be close to the mean. For this one, when they have a larger standard deviation, means the data is more spread out. Okay, so this is gonna be the idea of the standard deviation. I will talk more about it in the later sessions, okay? Let's go back to the PowerPoint. Okay, look at this example. The graph below shows the distribution of the amount of particulate matter, or the smog, in the air in 333 cities in the United States in 2008. has reported by the Environmental Protection Agency. The mean particulate matter is 10.7 micrograms per cubic meter, and the standard deviation is 2.6 micrograms per cubic meter. So this time they're gonna give them the mean. Okay, mean is 10.7, so somewhere like here, and the standard deviation will be 2.6 micrograms. 2.6, this is talking about one distance above the mean. Okay, find the level of particulate matter, one standard deviation above the mean and one standard deviation below the mean. Okay, so the mean is going to be 10.7, somewhere like here. We're going to add one standard deviation in here. So 10.7 will be the mean plus one standard deviation, which is talking about 13.3 micrograms per cubic meter. So 13.3, somewhere like here. This is one standard deviation. And then we want to calculate one standard deviation below the mean. So we're going to subtract, do the subtraction. The mean minus one standard deviation, which is going to be 8.1 micrograms per cubic meter. So 8.1, somewhere like here. Okay, so you can see the majority of the data is going to be lying within one standard deviation, right? This is true. And then now, number 2, keeping in mind that the EPA says that the level over 15 micrograms per cubic meter are unsafe. What can we conclude about the air quality of most of the cities in these samples? So 15 micrograms is somewhere like here. Okay, this is going to be 15. So think about it, is the air quality of the most of the cities in the sample is it safe or unsafe? Remember, for the number 1, the majority of the data is going to be staying within one standard deviation, which is going to be from 8.1 to 13.3. Whilst now, they do have a 15 micrograms. Okay, 15 is somewhere like here. So we're going to know 13.3 for the one standard deviation, which is less than 15 micrograms per cubic meter. So the air quality in the most of the city in this sample is safe. Okay, so we talk about the concept about the standard deviation. Now, let's learn how to calculate the standard deviation using the formula and also by calculator. So you're gonna see this is the standard deviation. Hey, remember that the S represent the standard deviation. I need you guys remember the notation, okay? And then the square root of, this is called summation notation. We're gonna add it all up, and that's a parenthesis. So the data for each data minus the sample mean, and then you're gonna take square. This is talk about you need to keep working on it. You will have a x1 minus sample mean square plus x2 minus the sample mean take square plus the x3 minus the sample mean take square, and keep going until the end of the data. And then divided by n minus 1. The n is talking about the sample size. How many data do you have? Okay, I will introduce the 2 standard deviation formula, and I show you guys the example. On the exam, you only need to pick either one of it. Okay, let's try 2 formula for the standard deviation. Just only pick one for yourself. Look at this example. You and your friends have just measured the height of dogs. The height at the shoulders are 600 millimeter, 470 millimeter, 170, and 430, and 300. Find out the sample mean and the sample standard deviation. Okay, first part, I need you guys use the formula to find out the sample mean. Okay, make sure you write down the notation for the sample mean. Okay, check the word for the sample mean. Write down the formula. I need to see this on the exam, okay? X bar, the sample mean, equal to sum of all the data. You're gonna add up all this data divided by n. What's your n equal to? 1, 2, 3, 4, 5. Okay, so all your word and then give me the final answer here. Okay, so we find it out. The average, the sample mean will be 394. Okay, now let's work on the standard deviation. Okay, so now you're gonna plug in the data, the x, talking about your data. So the first one will be 600 minus 394, take square, plus second data, 470 minus 394 and then square. You should have this guy here. Okay, right? X represent the data. So first data, second, third, fourth, fifth. And then subtract the sample mean and take square for each of them and add it all up. Divided by, we have a 5 data minus 1. Okay, so instead of using the calculator, it may be easier for you guys using the table. So here, x, which is going to be a 600 minus 394. Okay. And then once you subtract it, you're going to take square. You will have this guy here. So I want you guys try to finish this table and then at the end here, add it all up to find the total. Okay, check your work. You're gonna take square and then add it all up. Okay, this is the total. This guy will be equivalent for the numerator here. So you should have this one divided by 4. And then the standard deviation will be equal to 164.71. Okay, this is how you guys finding the standard deviation. So this is the first method, first formula. Okay, now let me introduce this another formula here, and then we're gonna work on the same example. Second one. The formula for the standard deviation is, okay, this guy, this is talking about the n, the sample size, equal to summation of x squared. Okay, so for each data, you're gonna take square and then minus the summation of x and then take square. It looks complicated, but I think the second formula will be easier. Okay, I'm gonna show you guys the example. Same example here, finding the mean, okay? And then I will be using the table like this. The x, I will just write it down the data. Okay, the x represent the data 600, 470, 170, 430, and 300. And then I need you guys add it all up here. That will be the summation of x. It will be equivalent for this guy. And then x squared, you just take square for this one and then add it all up. So the summation of x squared will be equal to this guy. Okay, try. Okay, so check your work. Take square of the 600. Okay, and then add it all up. Okay, now we're gonna plug into the formula. Okay, so summation x squared, that will be this guy here, and summation x, that will be here. And then use your calculator, you will get this guy. That's the same answer as the example 2. So again, you only need to remember one of the formula, okay? Find one which is easier for you. And on the exam, I want you guys to show me the work, okay? This is the instruction how you find the standard deviation using the TI-84 calculator. Actually, this is exactly the same thing how you guys use the calculator find out the sample mean. Okay, the step is exactly the same thing. But that's the one thing I need you guys to pay attention on. On the calculator, the standard deviation for the sample is given by, you could see the notation. That's the S and then the X in here. Okay, this is because sometimes you may have a two set of the data and the calculator will be separate to SX or SY like that way. But this is not the real notation when we write it on the standard deviation. Okay, we only use the S. That's a no X or Y in here. So make sure on the exam, you don't put S, X in here, okay? Only put the S for the sample standard deviation. Okay, let's try it together using the example 2 or example 3. So we're gonna go to the step. Number 1, added. Okay, let me clean up the first one. So I'm gonna highlight the L1, click clear, enter. Now I'm gonna input the data. So 600, enter, 470, enter, 170. Okay, so I do have a 5 data, the last one will be 300. Now we're gonna click on the stat, click on the cal, enter for one variable statistic. My data is gonna be on L1, or you could choose second 1 for L1, second 2 for L2. And then go to the calculate, enter. Okay, so you're gonna see we have the sample mean 394, and then we have the sample standard deviation 164.71. We have the sample size n equal to 5. And actually, how come I recommend using the second formula? Because here on your calculator, they find it out the summation x already. Okay, that's a summation x. Summation x squared, summation x squared. So if you're using the second formula, you could just using the calculator in this part and plug in these two guys. Okay, and then you can calculate the sample standard deviation. So that's why I will be using the second formula. Okay, variance. Variance is the standard deviation square. Okay, so you do have the same formula, just the standard deviation. Usually we don't plug in for the formula for the variance. We will just calculate the standard deviation and then take square, that will become the variance. And the standard deviation is preferred over the variance since it has the same unit as the original data set. Okay, for the unit, for the variance, that will be the square unit. So we may want to prefer standard deviation with the same unit. Okay, example 4. I want you guys try to do it by yourself. We find out the mean already. This is the example 1. Okay, we've already found out the sample mean. So now I only need you guys find the standard deviation and then take square of this answer, that will become the variance, and then interpret the standard deviation, okay? 1 to 3 decimal space, please. Okay, check your work. That will be the standard deviation. Okay, so variance, we're gonna take square of the standard deviation, sample mean, standard deviation. Okay, my bad. It should be 1 to 2 decimal space instead. Okay, not 3 decimal space. So this is gonna be 0.09 here. And then interpretation of the standard deviation. So we're gonna say, at most of this gas station, the price of gallon of gas is within 9 cents of $3.02 in here. Okay, so one standard deviation below or above the mean. So 9 cents of the $3.02. So for these sessions, you guys learn how to finding the sample mean and the sample standard deviation. I teach you guys how to use the formula and the calculator. You guys need to know both of them. On the exam, I will ask you guys how to find the mean, standard deviation, or variance. I need you guys show me all your work. Okay, not only the final answer. I need to see the formula, see how you guys plug in the numbers and the final answer, and make sure you guys remember all the notation. I need to see this notation on your exam as well. Okay, that's it.